Okay. So today we are going to start this new chapter, quadrilaterals, right? So very first we should know what is a quadrilateral, right? Okay. So as you can see the name quadri means four, right? Quadri means the meaning of the word quadri means four. Lateral means side, right? So four-sided figure which is having four sides, right, is a quadrilateral, right? So any figure which is having four sides can be called as a quadrilateral, right? So quadrilateral is a broader category of the polygon. It is a polygon having four sides, right? Now into this we have different categories, right? I hope you have already learned these things in your previous classes, but we will revise them quickly, right? Okay, to move further, like what are the theorems related to it, right? I hope everybody getting my voice and everybody can see my screen. Okay, so I hope everybody know, like everybody is familiar with vertices, sides, adjacent side, diagonal, opposite sides, consecutive angles, opposite angles, right? So these are the terms which are related to geometry, right? And we should know these terms in order to understand the theorems properly, right? So I have assumed that you have already know this, right? If anybody having any doubt related to these terms, you can tell me, I will explain, right? Now, coming to the different types of quadrilaterals, right? So what are the different types of quadrilaterals? Types of quadrilaterals. In this, we have parallelogram, right? Parallelogram is a quadrilateral, isn't it? Yes or no? In parallelogram, what is its characteristic? In which both pair of opposite sides are parallel, then it is called a parallelogram. Yes or no? Right? Both pairs of opposite sides are parallel, right? Then it is a parallelogram. I'm writing in short, right? Because I know you already know these things, right? Rectangle. Rectangle is a quadrilateral and it is a parallelogram too. Okay. So rectangle is a parallelogram, one of whose angle is 90 degrees, right? So what is a rectangle? A parallelogram one of whose angle is 90 degrees, right? That is a rectangle. Is that clear? Okay. Opposite sides are already parallel because this is a parallelogram and one of the angle is 90 degrees, right? Third is square. Square is also a parallelogram whose all sides are equal and one of whose angle is 90 degrees, right? So this is also a parallelogram. So square is a parallelogram whose, everybody please note it down, whose all sides are equal and one of whose angle is 90 degrees. That is a square. So square and rectangle are parallelogram. Getting that? Then we have a rhombus. What is a rhombus? Rhombus is again a parallelogram having all sides equal, right? So this is also a parallelogram. A parallelogram whose all sides are equal, right? So any parallelogram having all sides are equal, that is a rhombus, right? So do you think that square is a rhombus? Yes or no? Please tell me. Because the necessary and sufficient condition for a quadrilateral to be rhombus, a parallelogram to be rhombus, is that its all sides are equal. Opposite sides are parallel and all sides are equal, right? And this condition is also satisfied by the square, right? So square is a rhombus, right? Okay. So square is a special case. It is a parallelogram. It is a rhombus too, right? Is that clear? Then we have a trapezium. Trapezium. What is trapezium? It is a quadrilateral having one pair of opposite side parallel, right? It is different from parallelogram, right? Okay, so write it. A quadrilateral having one pair, only one pair of opposite side is parallel. One pair of opposite side is parallel, right? So what is the necessary and sufficient condition for a quadrilateral to be trapezium is that it is having only one pair of opposite side is parallel. Are you getting that? Okay. So what do you think about a parallelogram? Is this a trapezium? Can you call parallelogram a trapezium? Yes or no? Can anybody tell? Rudra. Can we call parallelogram as a trapezium? Tell me quickly. See, if you have any quadrilateral and if one pair of opposite side is parallel, it can be referred as a trapezium. उससे ज्यादा हो सकता है, उससे कम नहीं होना चाहिए, right? But parallelogram have both pair of opposite side parallel. It is a trapezium. Okay, so parallelogram is a special case of trapezium. Parallelogram is a trapezium. एक pair तो है ना parallel, right? So that is the only condition for a quadrilateral to be trapezium, that one pair of opposite side is parallel. We are not saying anything about the non-opposite sides. Sorry, another pair of opposite side, right? It may be parallel, it may not be parallel, right? So parallelogram is a trapezium. Are you getting my point? Parallelogram is a trapezium. Rectangle, square, rhombus, all are trapezium. Everybody getting this?
Yes, ma'am.
Okay, so for a quadrilateral to be a trapezium, the only condition is that it should have one pair of opposite side which is parallel. अब दूसरा जो pair है वो parallel हो भी सकता है और नहीं भी हो सकता. If it is not, then we call it as trapezium, right? If yes, it is both the pair of opposite sides are parallel, then that trapezium is called parallelogram, right? Now, if one angle is 90 degree, rectangle. If in the parallelogram one angle is 90 degree and all sides are equal, it is a square, right? Okay, so these are all special cases, right? So all these figures which you have seen earlier, right? Parallelogram, rectangle, square, rhombus, all are trapezium. Everybody getting that? Okay, so trapezium is where one pair of opposite side are parallel, right? Both sides can also be parallel. That is also a trapezium, right? Okay, then sixth is isosceles trapezium. Isosceles trapezium. Now, what is isosceles trapezium? Isosceles trapezium, where the two non-parallel sides of the trapezium are equal, right? Okay, so what is it? If two non-parallel side of a trapezium are equal, they are equal in length, then that figure is called an isosceles trapezium. Everybody getting that? Right? So trapezium can be like, if we have this type of figure, right? So this is trapezium, where only one pair of opposite side is parallel, AB, CD, right? AB is parallel to CD, right? And other pair of opposite side, which is not parallel, having different heights. So AD is not equal to BC. Getting that? But if it is so, means if you have a figure like this, right? ABCD, where AB is parallel to CD and AD, non-parallel sides, AD and BC are equal in length. Then such figure, such trapezium is called isosceles trapezium. Everybody getting this? What is the difference between trapezium and isosceles trapezium? Yes or no? Please tell me. Now the next quadrilateral we have is kite. Now what is a kite? A quadrilateral in which two pairs of adjacent sides are equal. Now, in this type of figure, we are not talking about the opposite sides. We are talking about the adjacent sides, right? So, a quadrilateral in which both pair of adjacent sides are equal, right? Two pair of adjacent sides are equal. That figure is a kite, right? So, what kind of figure it is? It's like this. These are the two adjacent sides, right? And they are equal. Diamond kind of shape, right? Kite of shape. Is that clear? Like a kite, and that's the reason it is called as kite. A, B, C, D, right? So what are the adjacent pair of sides here, which are equal? AB. AB is equal to AD, right? This is equal to this, right? And similarly, BC is equal to CD. BC is equal to DC, right? So you can see here that the pair of adjacent sides are equal. यहाँ पर हम opposite side की बात नहीं कर रहे हैं, adjacent side की बात कर रहे हैं, right? Okay, and such figure is kite. Is that clear? Right? So the two pair of adjacent side here are equal, and this type of figure is kite. So now, if we summarize this in a whole, right? So what we can summarize? Quadrilateral. Quadrilateral can be of two types only. There are only two broad categories of quadrilateral, right? One is trapezium and other is kite. Only two broad categories are there for quadrilateral. Now within trapezium, we have all the categories, that is parallelogram, rectangle, square, rhombus. Every figure is a trapezium. Are you getting this? Okay, and why? I told you that. If anybody having any doubt related to this, can tell me. Right? Parallelogram, rectangle, square, rhombus, right? These are all trapeziums. Is that clear? And you already know that these are the part of parallelogram also, right? So we have this category, right? Or you can say in the other way, you can write down like nothing. Please write down these things. In this, we have isosceles trapezium. Okay. Parallelogram. In parallelogram, we have these categories. What I have told you, that is rectangle, square, and rhombus. Okay. So I hope now you can relate these all types of figures, right? Why? Because it is important to understand them to get their characteristics quickly, right? Is it clear? Okay. Now, from this thing, we can say that, just note down some important points which I told you in between, that rectangle, square, and rhombus are all parallelograms. Okay. Another point, a parallelogram is a trapezium. Everybody is writing, yes or no? Please tell me. But trapezium is not a parallelogram. Okay, trapezium is not a parallelogram. Every parallelogram is a trapezium, but trapezium is not a parallelogram, right? A square is both a rectangle and a rhombus, right? और parallelogram तो है ही square, right? Kite, a kite is not a parallelogram. Okay, and a rectangle or a rhombus is not necessarily a square, right? Square is rectangle, square is a rhombus, square is a parallelogram, right? But rectangles, rhombus, or parallelogram are not a square. Okay, so square is a special case. It is that special figure which comes into the category of, it is a trapezium also, it is a parallelogram also, it is a rectangle also, it is a rhombus also, right? So this is an ideal figure, you can say, square, right? ये क्वाड्रिलेटरल भी है, ये ट्रेपेजियम भी है, ये पैरेललोग्राम भी है, ये रेक्टेंगल भी है, ये रोम्बस भी है. Square is everything, right? Except kite. Is that clear? Everybody getting this? Yes or no? Coming to theorem number 1, and it says that the sum of all the four angles, the sum of all the four angles of a quadrilateral is 360 degrees. Okay, so this is the first theorem. What is that? Sum of all the four angles of a quadrilateral is 360 degrees, right? Okay, as in triangle we have sum of all the angles of a triangle is 180 degree. For quadrilateral, sum of all the four angles is 360 degrees. Is that clear? Please note down. Everybody please note down. Now let's see what are the properties of the parallelogram. For a parallelogram, each diagonal divides the parallelogram into two congruent triangles. Okay. Second property, opposite sides are equal. Opposite sides opposite angles, not side this time, opposite angles are equal, right? Okay. So opposite sides are equal, opposite angles are equal. Each diagonals divides the parallelogram into two congruent triangles, right? Means each diagonal bisect the parallelogram, right? And the fourth one is diagonals bisect each other. These are important properties, right? Because we are going to use these property while doing the questions. So if you don't know the properties, then it would be difficult for you to find out the answer, right? Sometimes it is given in the question that this is a parallelogram. So as soon as it is given in this question that this is a parallelogram, its properties applies, right? Okay. So in a parallelogram, opposite sides are equal, opposite angles are equal, each diagonal bisects the parallelogram, and diagonals bisect each other. Okay, so these are the properties of parallelogram, right? And we can use these properties as theorems, and we can use this theorem in the converse way also. Is that clear? Right? Okay. Please note. So a quadrilateral is a parallelogram. A quadrilateral is a parallelogram if the first one, if both pairs of opposite sides are equal, or if both pairs of opposite angles are equal, or third, if the diagonals bisect each other, or the fourth one, if a pair of opposite sides are equal and parallel. Equal and parallel. So if you have proved any of these conditions, then you can easily prove that quadrilateral is a parallelogram. Okay, so quadrilateral is a parallelogram if you have proved that both pair of opposite angles are equal, or if you have proved that both pair of opposite sides are equal, right? So if you prove any of these conditions, any of these is requirement, right? Then that quadrilateral will be a parallelogram. Okay, so just note it down. We'll do the theorems related to this. Okay. Now, so these are some results on rectangle, rhombus, and square. Like each angle of a rectangle is a right angle. Diagonals of a rectangle are equal. Diagonals of a rhombus bisect each other at right angles, means they are perpendicular bisector of each other. And in the converse way, if we want to use this theorem, that if the diagonals of a quadrilateral bisect each other at right angles, then it is a rhombus. Okay. Then next is diagonals of a square. The diagonals of a square are equal and bisect each other at right angles. Okay. Diagonals of a square are equal and bisect each other at right angles. Right? We can also use this in the converse way, that if the diagonals of a quadrilateral are equal and bisect each other at right angles, then that is a square. That quadrilateral is a square. But for rhombus, diagonals are not equal. Right? Is it clear? So this is the difference between a rhombus and a square. Square is a rhombus, but rhombus is not a square. Right? Because for rhombus, the diagonals may be equal, may not be equal. Right? So square is a special case of rhombus where diagonals are equal. Getting that? Right? So these are certain results on rectangle, rhombus, and square. Please note down. So now let's prove these theorems, whatever we have discussed. Theorem number 2, a diagonal of a parallelogram divides it into two congruent triangles.
Hello.
Yes, Rudra, tell me. Now, we have to prove this. The diagonal of a parallelogram divides it into two congruent triangles. Suppose, so this is, we have to prove. Now, what is given? Suppose we have a parallelogram, right? ABCD. This is a short, how we write parallelogram in short. Two parallel lines, then GM, right? So don't confuse. So parallelogram ABCD, right? Here AB is parallel to CD, right? Or rather you can say DC. AB is parallel to DC. And AD is parallel to BC, right? And the parallelogram is, draw the figure. There's a parallelogram A, B, C, and D. Okay, so given is that ABCD is a parallelogram, right? Now, what we have to prove? To prove that the diagonal of the parallelogram. So let's first draw a diagonal here. So suppose this is the diagonal. AC is the diagonal, right? Now we have to prove that triangle ABC is congruent to triangle CBE, right? This we have to prove. The diagonal of a parallelogram divides into two congruent triangles, right? So we have to prove that triangle ABC and triangle CDA, these are two congruent triangles. Okay, this is we have to prove, right? Now, so we have to prove that these two triangles are congruent, right? So we have drawn here the diagonal AC, right? Now we will prove. Now look at these two triangles. In triangle ABC and triangle CDA, right? What do we have? Triangle ABC and CDA. Can you see if we name these angles? Suppose this is your angle 1, okay? Angle 2. So can you see that angle 1 and angle 2 are alternate interior angles? Yes or no? Right? Where AB and CD are the two parallel lines, right? AB और CD आपकी दो parallel line है, ठीक है? और ये जो AC है ये transversal की तरह behave करेगी, right? This diagonal will behave as a transversal, where angle 1 and angle 2 are alternate interior angles, and for such pair of line when cut by the transversal, alternate pair of interior angles are equal. Yes or no? So can we say that angle 1 is equal to angle 2? Are you getting my point? Yes or no? Right? Angle 1 is equals to angle 2. Why? Alternate interior angles. Right? As AB is parallel to DC and CA is the transversal. Getting that? So these two parallel line AB and CD is cutting by the third line, the transversal CA, and therefore the alternate interior pair of angles will be equal. Similarly, angle 3 is equal to angle 4. Now, what are 3 and 4? This is the another pair of alternate interior angles. This is 3 and this is 4. Right? So angle 3 and angle 4 will be equal. Again, why? Alternate pair of interior angles. Alternate interior angles. Now this time, what are the parallel lines? BC and AD are the parallel lines. Right? BC, this one is BC. Everybody getting this? And this is AD. ये वाली दोनों parallel lines है. Cutting by the third line, this diagonal line, AC or CA, right? CA is the transversal. Right? So when two parallel lines cut by the third line at two distinct points, the alternate pair of interior angles are equal. So angle 3 और angle 4 जो है यहाँ पर alternate interior angles है. ठीक है? क्योंकि BC और AD parallel है, क्योंकि ये parallelogram है, right? तो ये alternate interior pair हमेशा equal होगा. Is that clear? Yes or no? Everybody getting this? Yes, Rudra, are you getting this?
Yes, ma'am.
Okay. These theorems you have already done in your previous classes also, right? We are using the same thing here. Right? Now, so two pair of angles we have proved that they are equal, and the line AC. ये line जो है दोनों angles में common है, दोनों triangles में, right? Okay. So AC and CA are common. This is the common line. Right? So can we say that triangle ABC is congruent to triangle CDA? By which criteria? Angle, side. ये angle, ये side. Right? By the criteria AAS. Right now. By AAS criteria. Is that clear? Okay. So in this way, we have proved that the diagonal of a parallelogram divides it into two congruent points. I hope you're getting this, right? We have proved that diagonal bisect the parallelogram into two congruent triangles. Okay. The same thing you can repeat with the second diagonal, the other diagonal. And this time we can prove that triangle ABD, right? ये वाला triangle. This triangle is congruent to CDB, right? Exactly in the same way, right? So, however, I'm not writing here. This you can try on your own, right? Okay. So in this way, we have proved this theorem that a diagonal of a parallelogram divides it into two congruent triangles. Please write down. So we have proved this, right? Now, since we have proved that these two triangles are congruent, we can easily prove that opposite sides are equal and opposite angles are equal, right? So these are another theorems now, right? So write down theorem number 3. In a parallelogram, opposite sides are equal. Now to prove this, we need to first prove that the two triangles are congruent, which we have done in this earlier theorem, theorem number 2, right? So I'm not going to tell you this again, but if question comes in an exam, you have to show this whole thing. Is that clear? So in continuation of this, write down, as we have already proved, in above theorem 2, that triangle ABC is congruent to triangle CDA, right? Therefore, since these triangles are congruent, we can say that other corresponding parts will be equal, right? Congruent same होने का मतलब सारे parts equal होंगे, right? So AB will be equal to AB is equal to CD and BC is equal to AD, right? Okay, so opposite sides are parallel, right? So write down and BC is equal to AD by CPCP means corresponding parts of congruent triangles, right? So once we have proved that the triangles are congruent, we can easily say that sides will also be equal, right? Okay. So this is your theorem number 3, right? Next theorem. Theorem number 4. Now, if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Now, what kind of theorem is this? This is the converse theorem. Is it clear? This is a converse theorem, right? So each pair of opposite sides are equal, then it is a parallelogram. So this is a converse theorem. So what you can do is just try this theorem